Hi guys, welcome to Android tutorials. I'm Sandeep and let's get about the example program, Hello World program for Android. And firstly, let's talk about the steps that we are going to do here. And we create a very simple application and run it on real device or run it on emulator, and we examine its structures. So you can follow the Hello World tutorial that's present in developer.android, and you can start your Eclipse, start all programs and open your Eclipse, and we actually create an Android virtual device where you actually run your application into the Android virtual device and see how the application is looking. And before that, we create a new application in the Eclipse, and this is how actually the package contents or the package explorer looks when you create an application. So the very first is the Hello Android is the application name, and src is the folder where your packages all are present, and we generally give a package name with any of the naming conventions that could be a standard. And we create an Java file with the name that anything you want. And if you see the package contents, you find gen, where it is actually creating the same package name with our.java, and let's discuss about that later. And we go to the res folder where we actually spoke in the previous classes regarding the resource manager, where it is responsible for getting your layouts. So resource manager is the short form here is as res, where all the non-code components is present in this resources, which means that which doesn't have a logic or which doesn't have any kind of programming language. Instead it could be an XML or simple images. So drawable.hdpi, drawable.ldpi or drawable.mdpi are the folders where you had different kinds of images. So HDPI is high definition pixels and high density pixels, and LDPI is low density pixels, and MDPI is medium density pixels. So each of these images could be with 24 pixels or 48 by 48 pixels or 72 by 72 depending on the requirement, because in Android you find different kind of screen resolutions and you don't see one kind of screen resolutions or with same size or same width every time. So in order to match up your application design with all the screen resolutions available, you have to make sure that you are going to make it in a way, I mean you're going to make the design in a way that it's going to fit. So though the logic will be working out in all the resolutions, but images may or may not shrink or squeeze sometimes in different resolutions. For example, if I use only 24 by 24 pixel image for an icon, that icon could be looking on a very good, should be looking very nice when it goes to some kind of phones which is of HDP or some kind of other resolutions with 5-inch screens. But when the same application runs on 5.5 inch or greater than 5 plus inch of screen resolutions, you see that particular icon could be losing its clarity, or it gets shrinked, or it could be squeezed in order to match the logic that we have written. So that will something looks very odd to the user, or at least for a couple of users who are using a very big phones. So always Android will recommend you to put different resolution images in different folders so that you segregate them accordingly, and nothing you need to do, you just keep the images and application will be taking the images as per the font resolutions by default. And you see layout folder below the drawable images or drawable folders, where drawable consists of images and layout consists of layouts. So activity consists of an UI, and that particular UI will be actually designed in main.xml. So main.xml is actually responsible for what the UI you're going to look on your mobile application. So each and every screen that you see in a mobile application is going to be designed and will be saved in layout and with the .xml extension. And values is another folder which consists of strings.xml. Wherever you find, it's always recommended not to put any kind of hard-coded strings inside your program. So it's always better you use string.xml for that. In order to keep it, you add an entry for the string.xml and you can simply use it use r.strings. Anything that you created inside your Java program. And let's come back to r.java. So r.java is something links resources to the Java code. In the sense, you had so many resources below, which means that res is the resources, so which had drawable images, which had layouts, which has strings, which could have values and any kind. So all these resources, in order to get connected to this Java code that you write in hello android.java file, or you can call it as an activity, you generally need to have something in the middle layer. So that r.java will help you to link the resources with the Java code. So, and finally let's talk about the android manifest.xml, where android manifest.xml will is very similar to build.xml, where it shows you where to start and what is going to be the very first activity and what are the activities that are being present in this particular application, and which is going to be the launcher application and which is not going to be the launcher applications, and whether they had any services, any receivers, and what are the permissions that you are actually seeing. So whenever you install an application from Play Store or anything that copied from your phone or copied to your phone, you see the permissions showing you that your mobile phone or this application uses media, this application uses gallery, and that kind of all those messages comes when the respective permission is getting added in the android manifest.xml. So if you don't write any permission inside that, you see nothing. I mean, for example, if your application is going to talk with the content providers for images or contacts, you have to add the respective permission in the manifest.xml, android manifest.xml. So if you don't do that, it doesn't, or the application will not give you access to the content providers, which means that your application fails in getting the contacts or the images or any other content that you are actually trying to pull. And this is how the manifest XML actually looks. And the very first is the XML version. So you see a lot of XML files here in the Android for designing and for all the configuration things. And the version code, you see 1 and 1 point, version name 1.0. It's very important when you sign your application to your Play Store or any other Android market, because whenever there is an update, you increase these version codes and version names and make an update. If not, the Android Play Store doesn't accept your APK if it had already with the same version names. So you keep on increasing this version numbers while you had any updates or any changes to your applications that present in the Android market. And the very first line application Android icon equals to drawable icon and label string app underscore name is that it shows for your application. For example, your application needs to have an icon. Facebook had an icon, Facebook application had an icon with F, and WhatsApp had an icon with phone symbol on a green border. So each and every application will have some icon to represent that this is the application which is unique for this purpose. So in the same way, you actually give that particular icon that has to be installed in your phone is here. So whatever the icon will be, and you copy that icon in your drawable folders that is present in RES, and that icon is being copied here, or it can be given the path here so that it will be installed while installing the application. and the label. For example, your application had some name and you need that name to be coming below the icon in your phone. For example, you see Facebook icon, below the Facebook icon you had Facebook as the name of that application. In the same way, you want some label to be given, as it is not a good habit of putting the name here hard coded. It's always recommended you to write that strings in string.xml and give the path here. So that is how you give it. String slash app underscore name. You write app underscore name, you give a string to app underscore name in string.xml, and you are giving the path here so that your application gets the name from string.xml with app name. And activity Android name is something that which gives you the very first activity that you are actually going to run. Wherever you find intent filter, intent action.main and category.launcher, in the sense that this particular hello Android is the file or the activity that is going to be launched on the very first installation or whenever the user opens his application. So Android, hello Android is our Java file name that you are going to put it here, and dot always represents that it had a package. So this package will be this package, com.example.hello Android. This is how it you have to break this and understand. So this is the activity name. You can't call always this as Java files in Android. Whenever you create a Java file, you see how you're going to see how it actually looks, and we call it activity instead of calling it Java. You're going to see why it is called activity before in a couple of minutes. So as of now, let's say that as activity, and even that activity could have a label on the top of screen you want to show. If you want to show anything on the top of the screen for that activity, then you will give the same application name, or you can give that particular screen name, anything you want. And that is how you have to understand the manifest, and everything will be written inside the application. Anything you write outside the application will not be considered for this application. So anything you write, it has to be written inside the application, then it is considered to be configured well for the application. And before seeing why we call it as Android activity instead of Java class, we're going to see activity lifecycle now. So activity lifecycle is something that you should understand very clearly in order to understand how an application works. For example, you see the very first state. When an activity starts, it immediately goes to on create state. So on create state is nothing but it's a method. So it goes to on create state, and then again get called into on start, which means that the very first method tells you that an activity is created, and the second one tells you that on start, now activity just got started, and then it goes into on resume. So on resume is something that, so what is getting created or what came into on start, in the sense when you said on create, in the sense each and every activity had a face, in the sense it will have some UI that has to get loaded, or some view in order to get loaded. So that view will be loaded in on create state or on create method. So as I'm talking about the lifecycle method, on create method will actually load you the content, and later then it goes to on start, which means that it has completed its content loading till now. So on start, it has completed its content UI, and it's in on resume state, which means that it has come into something active state. So on start is something end of it, and on resume is something start of it. So you're going to start something, or when you go to other activity and you come back, it won't again go to on create on start, it again comes to on resume, which means that it is alive. it is not in pause or it is not in something. Now user can give some kind of input to that. So on resume state is some state where it is not in suspended state, where we can talk or we can say as it is an active state of an application. That is why you see the below on resume, you see in green activity is running. By this time your activity is completely created and you can see it, or user can see it. And then on freeze, and on freeze is something that the activity is in freeze state, which has got completely stuck or which has been not used for a long time, so it goes into a pause state. Pause state is something where activity is no longer active, or the activity may be seen, or whenever the lock screen has been closed, or when your phone is locked on particular activity, even then that particular activity goes into on pause state. So now your activity is no longer visible. Always put this point in your mind that whenever your application is on quick start, user is now no longer going to look at your activity. In the sense, he is not looking at your activity, that particular page. Maybe he had some other activity coming up on it, or he may completely closed it and went into another application. You can think it in that way. And on stop, which is another stage of pause, which has been so longer been in the pause, it will be controlled by the activity manager. We spoke in previous classes when the Android framework layer, you had activity manager, where it will take the time to make that particular application to go from on pause state to on stop state, which means now it is no longer visible and it's completely stopped. So if you want to run this activity or see this activity again, it has to start from on create. But when you are on pause, then you don't need to go to on create again. Instead you can go to on resume and see your application or your UI is still there. But once you go to on stop, either you have to go to on restart and come to start again, come to resume, or else you have to go to on create and create your UI back again. So after on stop and on destroy is called, where your activity has been completely removed out of the view, which means that there is no longer nothing visible on your view now, and there is nothing created or there is nothing been in the memory. So which means that if you want to see the view again, yes, you have to create that again. So again, that after on destroy, it's very common that it goes to activity shutdown, which means that you generally see that application got closed, but it still looks at will be in the background process. So when you see background process, it still stays in the background process, which means that the application state is still active, but the activity which got closed may not have been coming from the resume state, but it comes from the on create state again. And let's see activity from each other. So one screen, one activity, one UI. For example, you click on contacts. So when you click on contacts, the very first screen shows you my first contact, second one, and you see phone, call log, for favorites, and each of that is being an activity, which means it has its own UI and it doesn't change it, or it can't actually stay on the same page and change into another view, because each activity is other view. So if you want to load other view, you have to call other activity. So you clicked on my first contact, so now it opens up another screen where it shows you call home, 555234 is the number, and with some message icon smiley. So which means this is another activity which had this UI and different XML. And when you click on that particular contact, so now it shows you my first name, my first contact, phone number, and you can edit something. So edit contact. So each of the screens should be designed differently and should be called in different activities. Of course, in later stages you had a concept called fragments, where you can make it lightweight and reuse the components. But at this stage you have to understand that one activity will have one view, and one view can be called in only in one activity. So the same activity cannot be reused and again, because if I has to stay on the same activity and load another view, and the very first view is completely lost, and I'll get the new view. For example, if you see the second screen on my screen, where you see the first contact and second one, if I want to load, and let's call this activity as contacts activity, if I want to load the same page that was on there on the third one, if I want to load here itself, so I have to completely remove this view and load this. So when user clicks on the back button, now there is no chance of getting into this UI directly, because you completely removed this view and added this view to this one. So which means that you have to again, if you want to recreate this view again, you have to create it again and show it to user. So that is not something actually very easy thing for memory and for your heap, because you don't create a view each and every time. Instead you reuse it for the best of the time, because if you keep on viewing it again and recreating the views again, it takes a lot of time to view the components, and it's always something more costly task that you do it on a mobile. So don't load the views again and again. Instead, this is a good approach that you create different activities for each time, so that it will be easy for you. When you come back, you are not loading. So the best part of Android is you will have the back button on each and every phone without putting that on any of your screens. So you'll have back button somewhere here. So when you click on the back button, there is nothing you should do. It will simply remove this first view. For example, I had came from this screen to this screen and this screen to this screen, where I'm in edit contact. Now if I want to go back to this screen, it doesn't actually take me from here to here. What it does is it will remove this view from the stack, because when I traversed from here, this is the first view that has been, and on this one this view has been or this activity has been called. On this one again this activity has been called. So in order to go back now, I don't need to call this activity again. Instead, I can simply remove this particular activity from the stack so that this is visible. So which is very easy, and moreover there is nothing you are going to recreate everything in this view, because this view is already created, so you don't need to recreate anything. Instead you simply show it, but it will be on resume. It's not going to call on create and everything as we spoke before. So when you want to go from here to here, it's something that again you remove this from the stack, this activity from the stack, and you go to this screen. So it's a lot more easier when you create each and every activity differently and each and every XML differently to an activity. And let's revise the Android hello android.java, and this is how actually a Java file consists of. So you see, I told you before that hello android.java is called activity rather than a Java class. That is because each and every activity, or whatever the Java class extends activity, is by default. For example, if you create a Java class in Android SDK, so it by general, or if you create an activity here, you will definitely extend an activity to it. So which means that extending activity is something very compulsive here, because if you don't extend activity into your class, you will not be able to use that kind of things that you've been provided by SDK now, because a Java class will be working as a simple Java class but not like an activity. You can't convert a Java class without extending activity to your Java class. So that is why we write public class hello android extends activity almost to each and every part of everything that you are going to show. So which means that is why it's called activity rather than a Java class. So as I told you, the very first method in Android lifecycle is onCreate. So though you don't write the rest of the methods, they are actually called implicitly. So that doesn't mean that if I didn't call onResume, onPass, onStart or onDestroy, onStop here, doesn't mean that they are not getting called, they get called implicitly. But on create is the method that which I override it with particular view. So what am I overriding? So on create, as I told you in the previous diagram, that it will load some view. So what does it load? So now I'm creating a text view.tv, text view tv equals to new text y for this class, and I'm setting some text to that one, and I'm giving this text view to this set content view. So set content view is something that will load the UI to this activity. So what is the UI now? I created a text view. So this is called dynamic creation of text view here. So which means it doesn't have any XML layout. Instead, I'm going to create it simply here only a text view and giving it to the set content view. Instead, if I'm going to create a layout, I'll give here r.layout name. So instead of creating each and every part, but if you had a very complex or something huge UI, instead of only text view or instead of simple text, if you had huge components that you have to add, then it is always recommended that you create a new layout file and write set content view r.layout that particular layout name in order to load it. So here the UI gets loaded simply there, and you see the UI whenever you run this particular activity on your emulator on the real device, whatever it is. So that is how you run it. You simply have a run button on your top of this with a green color. So where you click it like a play button, and it loads up an emulator. If you are running it an emulator, we call it as AVD, Android Virtual Development or virtual device, which means it will create a virtual phone environment for this application and it runs it. So as I told you, it created a view for this. As it had only text, that text is getting reflected here. And in the manifest, when I showed you the string app name hello world, so whatever the name that is present, that is coming by here, that it has been declared in the Android manifest. So hello world by hand is some message that you actually written here. So that is why it is showing you, and that shows only when you say set content view TV. If you don't do this, there is nothing coming up here. It simply shows you a blank screen, or it crashes it saying that there is no view to load, because activity always needs a view, and without a view it doesn't load anything. And let's dig into some application fundamentals today. And as we know, the whole native code that we write for the Android development is in Java. So, and also of course the libraries or the application frameworks that has been given were also being written in Java. So it will be very easy for a Java developer who can simply dig into them if they had a good knowledge on Java. And a good separation, for example, when you compare with the applications other, you can make a good security for your application from other applications. Like you cannot make your application accessible from any other applications, so your applications will be safe enough to each application won't run on one. Instead, the application runs on its own process. For example, Linux is really popular for one of its quality, that each and every process in Linux had a ID called PID, which is unique for each process. So there is no chance of one process having the same or two processes having the same kind of IDs, so that they get collide somewhere in the process. So this generally doesn't happen in Linux environment, or of course any kind of OS environments. And here in the same Android applications, you have the same kind of qualities, like each application run in its own process. So each process has its own separate VM, which means DVM, Dalvik Virtual Machine. So the environment is different and the process is different. So there is no collision of the applications, or there is no such kind of thing like each and every application can be accessing by other applications. Because if I know that if I had an application in my phone, there is no way that whether I could see there is any other application I could access from my application, unless they are having the special kind of permissions. So each application is assigned with unique Linux user ID. So it's not only even with the OS level, it's also with the Linux user ID. As from Lollipop, you can see that administration account and guest accounts can also be created in phones. So where the guest applications can be accessed in one login only in the guest, and the administrator applications will be accessed only in the admin permissions but not in the guest. But guest applications can be done in the both the accounts. So which means that it's something making it visible and not visible according to the user requirements. It's not that can be simply explicitly exported. Like he can simply use the security concerns anywhere he wants for these applications to provide. Or as we know, applications or smartphones are always consisting of very sensible and sensitive informations. So where it should have full security and full privacy with no compromise. So you can use this kind of qualities that has been given by Linux process or Linux kernel, so that you can provide the security. And we have spoke this application components before as well, but let's go through them once so that we have a simple rollback for each of it. So activities will have a visual user interface focused on single thing and user can do. So that means that user can access something on the UI. It could be a button, it could be a text box or text view or anything that is clickable or linkable. And services, there is no such case that you should have a visual interface for these services. They generally run in the background and they keeps on doing any work that was being assigned to them. So they die in background silently and they start doing their work silently, and they simply deliver the goods they has to do. And broadcast receivers, where we see that whenever there is a broadcast that has been announced or sent from externally or internally, that could be received by the intent receivers, and that could be broadcast simply like a notification or an alarm or a dialogue, whatever the user want. And content providers allow to use the data exchange between the applications, between call logs, you can say photos, gallery, whatever that. So basic components of most applications, activity is one of the part of it. And there will be, and of course you call an application when there are several activities kept together and each activity does something different from other activity in order to make the application usage possible. So each is implemented as a subclass of base activity class, where we actually extend activity class as the parent class for each and every Java class you create. So each activity is actually acting as a subclass of the base activity class. So it has a default window to draw, which means that an activity will have a default window. Of course it could be a simple black screen, and the content of the window is a view. That's what. So when you said window, or it had activity had some default window, that is nothing but a view or a group of views. So group of views in the sense there could be linear layouts, different kinds of layouts, as we're going to speak them in further. So there are different kinds of linear layouts like linear layout, relative layout, and frame layout, and each has its own way of implementation. So the content of that window can be anything. It could be also the views like buttons, we'll call them button views, text field views, scroll bars, menu items, text boxes, etc. So at any point of time, if you want to see some kind of view which had some kind of elements on that, you just need to simply write set content view, and you have to keep these designs on whatever you want to see that in the XML, and you simply load it on set content view, and inside the bracket you write r.layout.a, that particular you give the layout name. And as we've seen, we go a little bit deep into the services now, and services actually does not have any visual interference or interface, where it doesn't have interface to see whether the service is doing anything or not, or it can simply run without even in the interface or with the interface, it doesn't matter. But the only thing we have to morely concentrate on that it doesn't interfere with any other application processes unless if there is a conflict. So when your application starts something in the background, the application will be working seamlessly even though there is something running in the service, or there's something running in the background, still your application runs very smoothly. For example, each and every application that you are running may not necessarily should have use a background service, but there are some applications that definitely use a service or definitely need a service. So in order to simply tell you one of those applications, say Facebook has some services running in the background in order to check your web services, or in order to check the updates, or in order to check any feeds coming in, going out, in order to give you some notifications. And each and every application necessarily may not have the service, but yes, if there is a necessity, you can write a service for that application and you can put it in the background without disturbing any other application flows. So there is another way of existing service. For example, you start a service and you don't stop a service. It itself stops itself whenever it finishes its work. But sometimes there are some services you want in that way that whenever you open a particular activity, then a particular service has to get started, and when a particular activity is closed, you want that service to get stopped. So there is this kind of requirements in some cases, so where you don't simply get disappointed. You can bind an existing service and control its operation by making it as on bind, and you'll have a method called bind and unbind kind of methods in the same service. So but instead of calling it service, we will call it as intent service, which means intent. There are different kinds of services, normal services and intent kind of services, or you call them bound services or unbound services. So bound services are always bound to a particular activity or to a particular class, which means they only run when the particular activity is running, but not when other activities were running. So in this sense, when I come to hello world.java activity, then it starts its service running, or it gets trigger, so it does some operation in the background. So when user finishes off his application or finishes off his work in that particular activity, he may go to some other activity now, which means that now the particular hello world.java class is completely gone into pause state or stop state, or also sometimes destroy. So you can't predict that. You can't do, or you can stop a service if you write simple service, or if you write an unbound service or a normal service. You don't have this kind of feasibility of stopping a service at any point of time, because or you can't bind it to our activity. When you start a service, that service keeps on running in the background and it doesn't adhere to any other activity here. But of course you can stop this stop that particular service by simply calling stop service and writing the service name at some other activity. But you will not be able to run particular service only on particular activity and stop it on particular activity and resume it on another particular activity. So if you want to use that kind of services, yes, you go with the bound services. And broadcast receivers, as we spoke, intent receivers or something like that before, receive and react to broadcast announcements, which means that when there is an intent coming out from somewhere, there is always chance of getting that receiving those intents and show it as a notification or show it as a any kind of alarm intent or anything. So anything you want. For example, broadcast can be low battery, power connected, shut down, time zone changed, etc. These all are actually the system defined broadcast. So there will be receiver for each of this one, where when you have a low battery, there will be a receiver, there will be a broadcast, or there will be a class that will broadcast this intent, and there will be a receiver to receive this intent and show you something. Similarly for power connected, shutdown, time zone changed, etc. And for other applications, can initiate broadcast. In the sense, even user can write some applications with intents. It's only not that only system applications can send you this, but not for others. You can write or initiate broadcast from any other applications if necessary. And content providers, that we actually spoke, and it is nothing but it's only way to transfer data between applications in Android. No shared files, shared memory, pipes, etc. It will this extends the class content provider. For example, if I want to get some data that was completely present in content provider, then I has to use content resolver or content provider in order to get the data from the content provider and use of it. For example, we see Gmail sync normally, where you see your contacts is completely synced with Gmail. So you write simply a content provider class, or extending a class extending content provider, which will give you all the contacts that was present within it, so that you take each of that contact and sync with the Gmail server. So it is always content provider who is responsible for putting any of the contacts inside and saving it there somewhere, or giving it to you, or accessing it from any other Java files. Content provider is responsible. And intents, as we spoke at before, intents are normally can be considered as verbs, and intents is actually an object with a message content. It could be for example, if I has to go from one activity to another, for example, I had activity A, activity B, activity C, and if I wants to go from activity A to activity B, I has to make an intent, or I has to start an intent that I am going from one activity to another. For example, you see services and broadcast receivers are also started by intents. For example, if I want to start an activity, or for example, if I am on A, I want to start B, then I will use intents to start it. In the same way, if I am running in an activity and I want to start a service, still then, even then, I will use intent to start a service. It could be any kind of service, but I will be using the intent to start the service. And broadcast receivers also use the intent service to get started. So intent is something that will initiate anything. So it could be start activity for result is something that you start an activity and expect some result from that, or simply start activity, which means that you want to start an other activity and you simply go from there, and it doesn't expect any kind of result out of that particular activity. You know, as you know, this activity actually returns a value every time. And shutdowning the components, this is one of the important thing we always actually has to think of, because whenever your application is completed, you has to release the resources that you actually has been consuming. Of course, most of the times it is something very dynamically happening, but still it is always safe that we can do it. We can terminate itself via finish. For example, I want to terminate a class in the sense, and I had A, B, C activities, and user had been traversed from A to B and B. But if I don't want C any much longer, but I want to stay in B, then I has to use finish, so that it will finish that particular activity. Wherever I write a finish, that means that particular activity is getting finished. So if I want to get to B, A, B to C scenario, if I want to get to B, I can simply call finish in C, so that it will kill C completely out of the stack, and you see activity B now. And for services, you have the same kind of functionality that finish does for activity. And services, you have to say stop self, which means that it stops itself whenever that particular service finishes its work, or you can simply call context.stop service at any point of time from your activity. So stop service is something that you call it from any activity you feel that it's no longer required to run, so you can simply call stop service, so that the service gets stopped in any of the activity you write. And stop self is a method that will help you to stop the service when you want to finish the service after finishing its work. And content providers, they are only active when responding to the content resolvers. In this sense, when you extend content providers and you make a connection with content resolvers and start pulling the contacts or photos or videos or any other content, only then they are active, and whenever you finish off the connection with the content providers, they are gone, they are now inactive, they get automatically closed. And broadcast receivers, and they are active only when the broadcasts are received. In this sense, I can tell you why. Broadcast receivers are something that they receive some signals from somewhere and do the appropriate task. For example, you got a notification, so it has to be active and alert you only when there is a notification. But for that, it has to check in the background every time that whether you got a notification or not, then it is a very big hit to your mobile application performance. So you can't write each and every in that case you will not write any receiver for any application, because it keeps on doing something in the background to check whether you got any notifications or alerts from the outside. But broadcast receiver doesn't actually work in that way. What they does is they will simply get active when there is a notification that coming from the outside, these get automatically poked. In this sense, these are not active unless there is some notification coming in. So there are different framework level applications that will actually call these broadcast receivers in the application in order to get them back or get them active. So they will be active only when responding to broadcast or when there is a broadcast there. And this we actually spoke that how an application manifest is been looking up, and it will have a Android name, and when you see these 3 dots, that means that it will have an intent filter, where intent filters we are going to discuss it further now. So intent filter is something that is responsible to show you which activity is going to launch first or which activity is not going to launch first. And let's talk about the intent filters here. And if you see the intent filter that has been written in below, frenetic activity, and the intent filter is something that you're saying action Android intent.action main, and it's saying Android.intent category.launcher, and in this sense the category it comes under is category.launcher, and the action it does is action.main, which means that shows in the launcher and is the main activity to start. So wherever you write intent.action.main and category.launcher, that is the activity which is going to launch and is going to be the main activity or the first activity to run your application or to open the activity that is present in that is opened on your start of your application. And there is another intent filter that you see where you see that is something like com.example.project.bounce, and MIME type is image/JPEG, and the category is category.default. What it actually does is it handles JPEG images in some way. In this sense, there could be some JPEG images that could be coming in from outside, or you could be selected from any of the content providers that are being handled by JPEG images in some way. So we can see that in the further classes anyhow, but that is to show you that there are different kinds of intent filters and different kind of categories in order to start an activity first and do some particular, very particular action for a activity. Thank you.